Welcome to Chapter 1, Section 5, Adding and Subtracting Real Numbers. We will be covering Common Core Standard 8.rn.3. Here we will use a number line to find each sum. Let's work on the first one. The first one says 3 plus 5. So starting at 0, we first move to 3. This is our 3. Now we're going to add 5 to that. And my number line is not quite long enough, so we're going to go 1, 2, 3, 4, 5. And of course the answer is 8. Now let's work on the second one. You should pick one or two of these to put these in your notes. You don't have to put all of them in your notes, but pick a couple of them. 3 plus a negative 5. So starting at 0, we're going to go to 3. That's our 3. Now we're going to add to that a negative 5. So we're going to go negative 5 this way. So we got 1, 2, 3, 4, 5. This is our negative 5. Negative direction, going this way, for a value of 5. And as you can see, our answer is positive. Now let's go ahead and do the third problem. Negative 3 plus 5. So we're going to start at 0 and we're going to go to negative 3. This is negative 3. Now from here we're going to add 5. So we're going the positive direction, 1, 2, 3, 4, 5. We're in the positive direction, 5. And as you can see, our answer is a positive 2. We can pick two of these and draw a number line and show them. For this last problem, you can see I've changed my line a little bit. We're going to do negative 3 plus a negative 5. So we're going to start at 0. We're going to go to the negative 3 position. Then from that, we're going to add a negative 5 position. You can see our answer was negative 8. I don't know if you remember last year, but we had another way of talking about adding integers. When we have a 3 plus 5, we can say we have 3 and we have 5. Well, if we have 3 and we have 5, we're going to have 8. In the second problem, you see that we have a positive sign and a negative sign next to each other. Those signs are different, so we're going to make them negative. So in this problem, we can say we have 3 and we owe, because of the negative sign, 5. Well, if you have $3 and you owe $5, you're going to end up owing $2, which is the answer of a negative 2. In the third problem, you owe 3 and you have 5. The 3 is negative and the 5 is positive. Well, if you owe 3 and you have 5, you're going to have 2, which is a positive $2. And as we look at the last problem, again, you will see that we have a plus and a minus. So this problem becomes minus 3. The plus and the minus becomes a minus 5. So you can think of this problem like you owe 3 and you owe 5. Well, if you owe 3 and you owe 5, you're going to owe 8, which is a negative 8 as an answer. Here's a definition for you. Write this definition in your notes. Opposites. Two numbers that are the same distance from 0 on a number line, but lie in opposite directions are called opposites. For example, 6 and negative 6 are opposites. When you're looking at this line, 6 is 6 units away from 0. Negative 6 is obviously also 6 units away from 0, but in the opposite direction. And here's a second definition for your notes. Inverse property of addition. For every real number a, there's an additive inverse. An a such that a plus negative a equals 0. So this relates to opposites. In the previous example, we had 6 plus, and then its opposite, negative 6. So not only are these opposites, but they're also additive inverses, because together they equal 0. So how can we use opposites and additive inverses? Well, to subtract any real number, you can think of subtraction as adding its opposite. For example, 8 minus 4 is the same as saying 8 plus negative 4. 8 minus 4, these two can go back to be minus, or 8 plus a negative 4. In either case, the answer is going to be 4. Now, when you subtract a negative, it's the same as adding a positive. So 5 minus a negative 6 is the same as saying 5 plus 6. These two negatives become a positive. Two positives there would stay a positive. So if in this little circle I've made, if the signs are different, it'll become negative. The signs are the same, it'll become positive. In the second example, 5 minus a negative 6 becomes 5 plus 6, which becomes 11. Here's another definition. Make sure you put it in your notes. The absolute value of a number is its distance from 0 on a number line. And we talked quite a bit about this last year. Absolute value is always positive. Absolute value is always positive. So you want to put in your notes the definition of absolute value, and then a note to yourself that absolute value is always positive. You may also have to put two examples that are shown here in your notes. Now, so far we've talked about adding and subtracting integers on a number line. We've talked about I have and I owe, and we've also talked about using the opposites. Here's the generic thought. You can add this to your notes or you can leave it out, whichever is most helpful to you. To add two numbers with the same sign, add their absolute values. The sum has the same sign as the addends. So if something has the same sign, you add their absolute value. If they have different signs, you subtract their absolute value. Here are 9 problems. I'd like you to pause this video and try these 9 problems. After you try them, I will go through and give you the answers. Then we'll talk about any questions you have in class tomorrow. So go ahead and pause this video and restart it as soon as you've attempted each of these 9 problems. Hopefully you've taken a moment and attempted these, and we'll go through the answers now. The first 3 problems refer to the question, what is the sum of negative 16 plus a negative 8? For this, the first question is asking if the addends have a same sign or different sign. And of course, they have the same sign. They are both negative. So when negative 16 and negative 8 are added, the answer will be, well, if you owe 16 and you owe 8, you're going to owe more money. So the answer is going to be negative. Now to go ahead and complete this, we're going to think about putting those two signs together, and that'll become negative. So negative 16, negative 8. I owe 16, I owe 8, so I'm going to owe 24, and that'll be my answer. Let's go on to the next problem. For the next problem, we're looking at negative 8 plus 9. In this case, the addends, negative 8 and 9, have different signs. When they're added, the answer will be, well, to determine what it will be, we need to look at these. Which one is farther from 0, negative 11 or 9? Which one's got the bigger distance from 0? Yes, the negative 11. Since the negative 11 has the bigger distance from 0, the answer will be negative. To think of it differently, we're going to owe $11 and have 9. Well, if we owe 11 and have 9, we're still going to owe money. Matter of fact, we will owe $2. Now for questions 7 and 8, we're going to consider 9 plus a negative 11. The addends in this exercise, you can ignore this part of the question. The addends of this exercise are the same or different. In this case, they're different. The 9 is positive and the 11 is negative. Complete this. The signs are different. That becomes negative. So we have 9 and we owe 11. Well, if we have 9 and we owe 11, we owe 2. Now, I'd like you to look for a moment at something. 9 minus 11 is very similar to minus 11 plus 9. Matter of fact, they're identical. Notice how the sign of the 9 is positive and the sign of 9 is positive. The sign of 11 is negative. The sign of this 11 is negative. In this case, they're the same equation because the sign has to follow the number it's with. Let's go ahead and look at the third problem. The third problem, or set, number 9, is going to be negative 6 plus a negative 2. To complete that, we're going to look at these. Signs are different, they become negative. So it's you owe 6 and you owe 2. Well, if you owe 6 and you owe 2, you're going to owe 8. If you have any questions on this, make sure you ask me in class tomorrow, and I'll see you then.